Good morning, everyone. We still have some people joining us from the waiting room, but thank y'all for joining us for our 6th weekly webinar Wednesday. Hope y'all are all enjoying the slightly cold and wet weather. It is the perfect time for a discussion on heat stress because so far we haven't had a whole lot of it yet. All right, so some quick housekeeping while we continue letting people into the meeting. You will notice that you've all been muted upon entry. This is just to cut down on any background chatter or any of that during the presentation. If you have a question at any time, y'all know me, I'm pretty informal. Just feel free to unmute and ask the question, throw it in the chat, or use the hand raise icon in your chat box. Quick housekeeping as far as the overall weekly webinar series goes. Like I said, this is our 6th one, which means we have recordings for the first 5 that are all available to be watched for credit on the Master Dairy website. To show me that you have gone back and watched those, all you need to do is fill out the evaluation form. And that's just the overall eval. All right, I got you, Rita. I'm glad you're joining us. All you need to do is fill out that eval sheet with your name, the one that you attended, and any feedback you have for us from the meeting. For any of you who attended the PC Darts session last week, if there's a particular topic you would like to hear about, feel free to write that in under any of the comments and I'll go through and look at those. Like we said last week, if you don't tell me what you want to hear, you're stuck hearing what can come out of my brain, which may not be overly applicable for you, depending on where my brain is that particular week. In order to receive credit for a single in-person Master Dairy meeting, you need to watch 3 of the webinars and tell me that you've done that. And that's just because each one of these is an hour long, and a usual in-service or usual Master Dairy meeting that's in person is 3 hours. The completion form can be accessed on our UT Dairy page or at this link, https://tiny.utk.edu/tmdp_form. If there are any agents who would like to view this recording for in-service credit, I would encourage you to go to Kate and pull that up on the UT Dairy playlist that we have there as well. All right, looks like we have most people in, so we'll get rocking and rolling. Can someone either unmute and tell me or write in the chat, can you see my slides okay? Yes, yes, yes. Perfect. Thank you, everyone. So like I talked about today, we're going to be talking about tips for managing heat stress mostly and the role of housing and ventilation in that management. And I'm going to stop my video just so we don't take up any more of that bandwidth. All right, so our plan for today, overview of heat stress and the role of housing and ventilation specifically. We know that heat stress is a major issue in every single species. We know it does things, especially in the Southeast, impacting our overall health and our production and our repro. We all expect to see that big slump in our production, that big slump in our reproductive efficiency every time the summer comes around in Tennessee. And all of those things lead to a big impact on our farm profitability, which there's a lot of things outside of our control right now on that, but every little bit that we can do with limited inputs definitely helps. So as far as places that we can experience it, heat stress doesn't really, it's equal opportunity. So we can experience heat stress in a pasture, we can experience it in a beef cow and a dairy cow across all breeds. We can also experience it along barns, no matter what type of barn we're talking about. It's a pretty equal opportunity stressor. So the main things that contribute to heat stress are different heat loads. So when we think about heat stress, we probably really only think about the sun beating down on us or stagnant air. But the thing that we need to think about is the different heat loads that come and affect our cattle. And one of the first ones that we talk about is conductive heat. And what that really is changing a heat exchange from whatever surface that animal is resting on to the animal herself. And it can go either way. It can go from the cow to the surface if the surface is cooler. So something like sand that doesn't hold a whole lot of heat could potentially cool cows during a heat stress period. Or if we use any of those conductive cooling beds, it's basically a water bed where you would run cool water through during heat stress environments to help cool your cows that way. But the reverse is also true. So if cows are out on pasture and the sun's beating down, that ground is also going to be warmer. And if it's warmer than that cow's external body temperature, it's going to pass heat directly from the ground to that cow. The next thing we want to think about is convective heat. And this is heat pulled in from any media where we would usually think about something like a liquid or something like a gas. So air is going to be the primary thing that's bringing heat onto our animals for our purposes with heat stress. It's also the reason that some people might want to use something like a cooling pond. This isn't a mastitis talk, but I will strongly encourage you, none of you, to let your cows use a cooling pond, especially our dairy people. Our moneymaker is this udder right here. And that's one of the first things that goes into the pond. And that just creates a super highway for all kinds of bacteria, algae, protozoa to go up in there and make a huge mess of our moneymaker. So if we can keep them out of the pond, it's generally a pretty good idea for our dairy cattle. But that'd be the overall theory, is that we put them into a cooler environment. That cooler water takes away some of that heat from those cows through convective heat transfer and overall cools them. If we're thinking about the air that those cows are in, if that air is warmer than her external body temperature, that is going to create extra heat load on the cow. Vice versa, if the air is cooler, so somewhere like Arizona where we can cool with misters, where we're literally cooling the air, heat transfer goes the other way. It moves from the cow into the air. Our last one is the one that we generally think of the most, which is going to be radiant heat. Now, I've used the sun here for this radiant heat load because that's usually what we think about as far as heat radiating from the sun onto those cows or onto us when we're tanning or onto our dogs and they're laying on the deck. But another thing I want you to think about is the radiant heat load from cow to cow. So if they're bunched together, like these ladies over here are, they're going to be radiating heat from one another. That's one of the reasons where we say to pay special attention to stocking density during heat stress periods. Because if our cows are crowded together, or if they feel the need to bunch, it's going to increase that overall heat load. So if we're looking at how animals regulate, we talked about how they accumulate heat. Let's talk about how they get rid of it. First one is conductive loss, exactly what we talked about before, right? If this resting surface is cooler than her overall body temperature, heat is going to move from the cow into the resting surface. The one we usually think about for this, like I said earlier, is sand, because it doesn't hold a whole lot of heat. Some of the research we did in compost-bedded pack barns also showed us that the surface temperature of the pack was 1 to 2 degrees cooler than the ambient temperature in the barn. And that's because there's evaporative water loss occurring right at that bubble, so at that top of the pack, which made it a little bit cooler. So it was experiencing evaporative cooling, which in turn then could theoretically cool that cow that was laying on top of it. The next one is going to be respiratory loss. And we usually think about that when we see that heavy open mouth panting that these ladies are doing. But even breathing out naturally is the main way that these girls are going to lose heat. There's another reason why we want to think about not overcrowding during the summer. Because if she's breathing out to try to get rid of more heat and the air she's breathing in is still hot because those girls are bunched together or we don't have fans, we don't have adequate air movement, it's not going to cool her as effectively as it could be. The last one we're going to talk about is evaporative loss, and we'll get more into the sprinklers and things like that at the very end of this presentation, but that's what we generally think about in Tennessee or in most of the Southeast is evaporative loss due to moving wind over those cows' back and evaporating that heat off of her, or literally wetting that coat down all the way to the skin and force drying her, taking away that heat with the water as it evaporates. We have some main signs that we want to look for, and I'm going to try to make this as interactive as possible, and we might stop after a minute if nobody responds in the chat, so respond at your own peril. We want to look for heat stress or stagnant air. One of the first things that we want to look for is air-seeking behavior. So I guess show of yeses or nos, who sees air-seeking behavior in this picture? Seeing some yeses, lots of yeses. Awesome. So what I'm looking for is those noses that are all the way out of the pack. And I know when I look at it the first time, I don't see quite as many because I'm focused on these girls right here. If I look down the entire length of the barn, even though the barn is nice and open, I can see 6 to 8 girls that are sticking their noses out of the barn looking for fresh air or looking for a cooler environment. Next thing is our traditional one, and we're looking at panting. And in this video, what you're gonna see is not the heavy open mouth panting. What you're seeing is an increased respiration rate. So watch the rises and falls of her side as she's breathing. You can see some of the other girls don't seem to be experiencing heat stress as much, but this girl is definitely breathing at a heavier rate than she would normally, so she's probably experiencing heat stress. Some other things we can think about are standing in stalls and perching. Now, this one is a little bit confounded with whether or not our stalls are actually the right size. So if our stalls are a little bit short or they're a little bit narrow, we tend to see some of this behavior anyway. But if the majority of our herd is standing up or perching in stalls, what they're trying to do is expose more of their overall surface area to air to get that cooling effect happening. So I do have a quick little poll for you. And my question is, when do you all think heat stress happens? And I'm going to launch the poll. And please respond. Y'all should be able to see it now. There's 4 options. I'm going to go ahead and end the poll and see if I can share the results with y'all. So hopefully y'all can see that right now. And we have a pretty clear winner, which is when temperatures are above 70 degrees, which is awesome. We had a couple thinking above 90 or above 80. And I'll tell on myself a little bit, even the temperatures above 70 isn't necessarily true for the area in which we live, because what we're really doing is looking at the temperature humidity index. So when we think about when cattle actually experience heat stress, it's not only dependent on the temperature that we're experiencing, it's also dependent on the relative humidity we have in our area. And if you look at the weather data for Tennessee, our lowest really ever goes down to 70% humidity. So right off the bat, we can already see that this chart only goes down to 72, but we're probably experiencing heat stress at a higher level of maybe 67, 68. So at that point, we already know these cows are experiencing mild heat stress, and this is most of our year in Tennessee, and we'll get to that a little bit later. We get into moderate heat stress, anywhere from 72 to 79 THI, that's this nice orange level right here, and severe heat stress at 80 to 89 THI. And remembering how much of our year stays 70% humidity or above, we spend quite a bit of time in moderate heat stress and severe heat stress levels in Tennessee. The trick that we can fall into as humans is when we go outside, we'll want to wait to turn on the fans until we feel uncomfortable, which is why we might say not until 80 or not until 90 degrees or not until it's actually in the summer. But we don't really start to experience those same issues with heat stress because our temperature humidity index is overall higher than what our dairy cows experience. I know a lot of y'all know that already, but what we're seeing is at that same level, 70, 75%, we're not really even into a caution level until we get up to 80 degrees outside. And we're not into extreme caution until we're in the upper to mid 80s. And then danger is not until we're getting up into the high 80s, low 90s, and extreme danger not until we're getting close to 100. And that's with that relative humidity above 70. So if we turn on fans based on when we feel uncomfortable, we can actually ding our production quite a bit by letting those cows experience moderate to mild heat stress for quite a long time. I put together this graph looking at overall maximum temperature humidity index, and the THI that we recommend using for dairy cattle is 68, because that's when we start to experience that mild heat stress. So this blue line right here, that's going to be our humidity. You'll notice it very rarely falls below 70% humidity. We're a nice wet state. And then our temperature is this green bar right here. And this is averages for Tennessee, taken from 20 or so areas, and it's just a general aggregate of what our averages are. This is not based on this year, because I think our temperature would be shifted down a little bit. And this orange line is our temperature humidity index from January all the way to December. So what we'll see is this red bar is our heat stress line. And we hit that line or go above it all the way from April and into October. If we look at individual days in each one of these months, we'll experience at least one heat stress day every month of the year, which is why we might want to do something like put our fans on a regulator based on temperature and humidity. Most of them just do temperature, but if we can keep this information in mind and considering turning on our fans around 65 or 70 at the very, very least, we can make sure that we try to limit those heat stress impacts in Tennessee. So we talked a little bit about the impacts. The biggest one that we generally think about is reduced milk production, because that heat stress can reduce milk production up to 12%. And that would be chronically affecting them over time, which is absolutely what we see here in Tennessee. We also see increased respiration rate, like we saw in that video, increased rectal temperature, and we'll see this one jump up really high if we don't have cooling in some place like the holding pen. I was doing a study with some farmers in Kentucky, and their fresh cows, every single one of them would test with a high temperature when I went in and assessed them twice a week, every week during the summer. And it took me a hot minute to realize that it wasn't because all of these girls were sick all of the time. It's because being crowded together in that holding pen, even though it was only for 15 to 30 minutes at a time, was still enough to increase that rectal temperature and cause heat stress on those animals because there wasn't adequate ventilation, adequate air movement, or adequate sprinklers in that area. We also see decreased feed intake, and that's going to have feedback ramifications on things like milk production, overall growth if we're talking about first calf heifers, and then also reproduction across all of our animals. Because of that, we see those increased maintenance requirements and impaired fertility. We're going to talk about some controls. We're going to go from simple to slightly more complicated. So the control that I'll see a lot is trees. Trees have a lot of pros. They reduce that radiant heat, that heat coming down from the sun, but they kind of increase that radiant heat moving from animal to animal because animals tend to bunch under the trees. They provide a cooler area. You'll actually feel the temperature drop when you walk under one of those shade trees in a pasture, and they can cover multiple animals. And most importantly, they're free. They tend to already be planted in the pastures or around the fence rows, so they're already there. Cons, they're immobile. You can't really move them from pasture to pasture. Once they're there, they're there. They tend to cause bunching, and I'm sure every single one of you has seen the creation of muddy spots that occurs underneath trees because cows like to gather around underneath them. Some additional things that I don't have listed here would be increased fly load by these cows bunching underneath the trees, but if we're focusing on heat stress, it can have some positives and some negatives. Another one that we think about is shade tarps, and we use these a lot at LSU when I was down there working on our dairy, and we had 2 or 3 in every single pasture that we would run our dry cows or our heifers in. Pros, it reduces radiant heat. Again, it blocks off that heat coming down from the sun. The nice thing about ours were they were mobile. These look a little bit less mobile, but ours were constructed out of old stainless steel pipe and then just a shade cloth. So we could attach our gator to them. We could attach, yes, the actual, drivable gator, not the ones that lived in the pond. And we could also use something like a 4-wheeler to move them strategically around the pasture, whether that was going back and forth towards a water source or just trying to limit muddy spots overall. They definitely can cover multiple animals. And if we're being a little bit fancier, we can pair them with fans. If we have a generator in the area, we can run lines and include some actual forced cooling with these as well. Cons, they do have some cost. Maintenance was a big thing in Louisiana because every time a hurricane blew through, it would mess up our shade tarps. Hurricanes are less of an issue here, but a tornado would definitely pick these up and throw them around. So they do require some maintenance and they do require some management. Routine holes are going to need to be fixed. You're going to need to occasionally stretch that shade tarp back out. And you really do need to rotate them around the pasture, or we have that same issue that we saw with the trees, creating muddy spots, creating bunching, and potentially increasing fly load. The last main one we're going to talk about are barns. So big pros with barns, they're a controlled environment, and it's more than just providing shade. We can include fans, we can include sprinklers, we can include easy access to water, easy access to feed, and a controlled lying environment as well. So those are some of the added benefits. If you've already got one existing, if you don't have one already existing, it's fully customizable. There are a lot of options for how to build a barn. There are a lot of options for the type of structures to put within your barn, as far as what you want your alleyway links to be, where you want to put your waterers, what kind of resting surface you want to have, whether you want to do something like a freestall or a compost barn. Lots and lots and lots of options. And we can retrofit older facilities that were not intended to be cattle barns into cattle barns. The cons are, though, they're expensive, and they have got to be built correctly in order to actually improve that heat stress on those animals and not make it a little bit worse. And they have to be managed. Barns have to have ventilation. It's not a, it would be nice, it's an absolute must. It would be like most of us today sitting in our houses, not having any kind of air exchange with the outside world, not any kind of air conditioning or heater, and relying solely on the windows that we may or may not have around our house that may or may not be open. So we have two main types of ventilation. We have natural and we have mechanical. And mechanical ventilation, that's things like fans, falls into two main types. So things that are supplemental, so that would be supplemental to natural ventilation, or full. And that would be something like a tunnel ventilated barn where we're relying on all of our air exchange and all of our cooling to come from those fans. And we do have several priority areas, and I'll be upfront with you, these have changed over time. Our old priority areas used to be our fresh cow, our high producers, and our low producers, then things like our holding pens, our milking area, and then finally would be our calving area and our close-up dry cows. Every year, it seems we learn more and more about the importance of getting our cows off to a right start, right at calving. So our first priority area is the calving area. We want to reduce any additional stress on those new mamas, and part of that is heat stress, especially in Tennessee where we live. The next one is going to be the close-up dry cows. We know the dry period has lasting effects on this next lactation. We also know that dry period management and heat stress in particular has lifelong impacts on the offspring born during heat stress. We know it reduces first calf heifer milk yield from animals that are born during heat stress. And we also know it can reduce fetal growth a little bit when we don't have heat abatement. Our next one is going to be the holding area, because we're talking about a very rapid development of heat stress when all of those animals are bunched together in the holding area. Next one's going to be the milking area or the parlor, then our fresh cows, then our high producers, then our low producers. Natural ventilation is called natural for a reason. We're relying on the free movement of air throughout a barn. And that means high sidewalls, so 14 to 16 foot high down here where we are. Ridge vents are a must. We want a 3-inch opening for each 10 foot of roof width and a minimum of 12 inches. So the smallest we ever want to go, no matter which structure we're in, is a foot, because we want that air to be able to adequately escape. And we'll go over some types of ridge vents and things to be mindful about when installing one or retrofitting in a few slides. And our roof pitch, we want it to be at least a 4 to a 12. The reason we want a steep roof pitch is we want to get that chimney effect. We want that hot air that we know that is rising off of our cows into our barn to have a quick, easy escape, to let new, fresh air into the barn. So we're really wanting a 2 to 4 mile per hour air movement through the barn. And we know from Kentucky data for sure, and for Tennessee data, I would assume, I did look for it, y'all. I had difficulty finding it. I'll keep looking. That throughout the year, natural ventilation, if our barn is sized right, can easily meet the 2 to 4 mile per hour air movement from the winter and into the summer. And we really want to promote air exchange through the barn. So here we have my crude barn drawing, and we have our happy little cow that's lying down and chewing her cud. What we want to happen is on these nice high sidewalls, air is going to move into the barn continuously, hot air is going to rise and move out of that ridge vent continuously. This is our ideal situation. Our unideal situation is not having a ridge vent or having a ridge vent that's sized too small. If that ridge vent is sized too small, it creates a choke point. So we'll still get some air that's escaping, but we won't get anywhere near as much. If we don't have a ridge vent at all, we don't exist in a vacuum, right? So some air exchange will happen, but new air cannot come in to take the place of the air that's in the barn until the air that's in the barn moves out. So lack of a ridge vent, having a shallow roof pitch, all of these things can be really big issues in dairy barns, especially in retrofit barns. Ridge vents, I'm a bit of a ridge vent nerd. I'm gonna fully tell on myself there. I think there are lots of really cool designs and lots of really interesting ways to use them. The three main ones that we tend to see in our area are an open ridge, so nothing at all, a ridge cap or a doghouse, or an overshot roof. We'll see overshots quite a bit, and there are some big problems we can see with overshots that we'll talk about with them in a minute. So with an open ridge, it's exactly what it sounds like. It's an opening that is cut into the top of the barn. And yes, sometimes we'll get precipitation catching or falling into the building, but generally in a barn that is well stocked, so stocked at capacity, not overstocked, there's enough buoyancy from the heat that those girls create and enough air movement that rain doesn't just continuously stream into the building. So remember, we don't exist in a vacuum, right? So that air is constantly moving out of the barn to keep all that precipitation from going straight into the barn. There was an alternative to this, which had a gutter running along the bottom to capture any water and take it out of the barn. I have concerns with that on the same way that I have concerns with things like a ridge cap or an overshot roof. Remember, we said we needed at least 3 inches of opening for every 10 foot of roof width, right? So that doesn't just apply to this opening right here. That applies to this opening, that applies to this opening right here, and these openings as well. And particularly on an overshot roof, what we'll see is this line is either shifted in and creates a choke point right here, or this line is shifted down and creates a choke point right here. So if all of those measurements are not the same, it doesn't matter that this right here is spaced correctly, because our choke point occurs from this roof line to this roof line, which still limits air escaping from the barn. We'll see the same thing with a ridge cap. If we open the barn the appropriate width, so let's just say for a foot, that we size this for a foot because that's what we need for our barn, but we only put our ridge cap up 3 or 4 inches or even 6 inches, we've still created a choke point having air escape from that barn. So that's something that we definitely need to be mindful of, especially in the Southeast, where we want to maximize that natural ventilation and we want to maximize that air movement through the barn. So we've got some pros and cons for our 3 main types. A big pro for an open ridge, remember that's that one that's just cut in, is air can escape from any direction. It doesn't matter which way the wind is flowing. It doesn't matter if we normally have a westerly wind and today we have an easterly wind, the air is going to escape no matter what. It is the easiest to add on. You're literally cutting a hole in the top of your roof that's appropriately sized. Some cons are some precipitation may enter the barn. So for example, if you're putting this in a holding area and you have a completely open ridge and there are no cows in there for the majority of the day, the floor is going to get wet because precipitation will fall through that opening. And you really need to protect trusses. Some options for this are multiple layers of weatherproof paint, using some kind of flashing or any kind of guard along the top of those trusses just to prevent rot. For the ridge cap, the pros are it's difficult for precipitation to enter the barn. Remember, this is also our doghouse because it has to make it through the sides instead of straight down. Air can still escape in any direction as long as we haven't created a choke point, and they're still not dependent on wind direction because it doesn't really care which way the wind is blowing. The cons are it's more expensive or difficult to install or add on. You've got to consider those choke points. You have to have braces to raise that ridge cap, and you have to have an additional cap that's put on top of your barn. An overshot roof is one that we'll see a lot in the Southeast. And the pros are, it's difficult for precipitation to enter the barn because it is completely overshot. There's not really a true opening into the barn. It has to blow in completely from the open side and then make it down. Trusses are protected is another big pro. The cons are, it is dependent on a prevailing wind direction. And what I mean by that is if we are up in the mountains and we know that our predominant wind direction always comes from the west, for this example, we're good, right? The wind is going to blow over here, help take this air away and move it off of the barn. Well, what happens on that day where instead of blowing in from the west, the wind decides to blow in from the east? Now we have air coming from this side that's going to create an additional barrier, basically, to air escaping from the barn through this opening. And that's what I mean by dependent on a prevailing wind direction. And it's also the easiest to create choke points. Like I said, that bottom lip will come up to meet the top, or that top will be shifted too far over and create a choke point of a couple inches, either on the bottom or the top opening. We talked about placing fans where they are needed in our priority area. I'm going to add a little bit more detail here onto our lactating cows. The first place that we want to put it, if you're prioritizing where to put fans, is going to be over the feed area. Again, because we bunch cows closely at the feeding area, we're intending to have them line up side by side by side and to stand there for a pretty big length of time. Our next place to put them is going to be the resting area. Just because we expect them to have a little bit more space there, we don't expect the resting area to be completely stocked all of the time. That's why we get away with things like overstocking. And we potentially have some conductive cooling there as well, particularly if we have something like sand where those cows are laying down on a cooler surface. There are lots of different options for fans. We have basket fans, panel fans, or box fans. And they all have pretty much similar attributes as far as the job that they will do in a barn of any kind. But they do have some spacing rules and some placement keys. We recently just published this extension pub, Mechanical Ventilation, Making It Work for You. It was myself, my previous mentor at UK, and a BESS engineer, Dr. Joseph Taraba. And we go into a lot more detail about different types of fans, whether or not we want to have guards, and some issues that we can get into with them as well. So that's a resource that I can send out to y'all later. I'll send it out with the update after this meeting. But the main key is we want to place those fans 10 times the blade diameter. We don't really want to go more than that. And we can maybe go shorter depending on the issues that we have in our barn, but we don't want to go further than 10 times the blade diameter. So if we see something like a 30-foot fan, it can be 30 feet in between fans along the length of the barn. So one fan in front of the other fan in front of the other fan, 30 feet. In between individual fans, so side by side, we don't want more than 6 to 8 feet between those rows. So if we're looking at something like a 3-foot fan, we're probably thinking 6 feet. If we're looking at a 4-foot fan or greater, we're probably looking at 8 feet between individual fans. And we want to put those at a 15 to a 20 degree angle pointing down towards the cows. And the reason we want to do that is we want to make sure that effective air movement is hitting those cows and that the effective air movement from one fan stops where the effective air movement from the next fan begins. And that's where we'll see these spacing keys really come into play. So fans don't just blow air in one direction, right? As those fans blow, that air will start to spread out in a cone, getting further and further apart and having less and less velocity as we go out from that initial fan. So kind of like my little squiggly line that I drew here. In order to effectively cool cows, we want to have a tight cone hitting those animals. So we want that next fan to come into play where that tight cone of air ends. So just because we stand in front of a fan and we can feel air movement maybe 20 to 30 times the diameter of that fan, that doesn't mean we're still getting effective air movement. And if we look at our cows, they'll tell us that. They'll all bunch really close to a fan, or you'll see really big dead spots in your barn where they're making sure they stay in that effective air movement zone. And to kind of show y'all this, I pulled this from that pub I mentioned earlier. So we have a bank of fans coming this way, and this is in a holding pen, so these cows are crowded together. This panel right here is showing us the ambient air temperature that these cows are experiencing. This picture is showing us the air velocity that those cows are experiencing. So blue is low and yellow is high across both of these pictures. The closer we are to the fan, the lower the ambient temperature is, and the higher the fan velocity is, that red or yellow. But you'll see pretty quickly after we hit these 4 cows, our velocity drops very rapidly down into the blue zone. Because again, that air doesn't exist in a vacuum, and it's just encountered these barriers in the form of cows. So these next 3 cows in line are getting a lower velocity and a higher temperature, and so on and so forth as we keep going back. Now, what I kind of want y'all to look at is around the side of the cows. So we see how it's still nice and pretty and yellow from that same fan bank all the way down to the back. Well, that's because we don't have anything impacting that air and keeping it from flowing right there. So I've talked to people about feeling air movement on the feed side of a feed alley. Well, yes, you will, because you don't have cows that are stacking up on the feed side of a feed alley. You have them in the actual alleyway where they're reaching their heads over to eat that ration, but you don't feel it on the side that you're going to walk on. So don't use that as your litmus test for whether or not your fans are working, because what you really want to make sure you're feeling is what the cows are feeling. And this is why in holding pens, our fan spacing rules are a little bit different. We want them a little bit tighter because we're expecting to have all of these barriers in front of our fans. The same thing would be true if you're in a barn and you have large structures in the way of typical fan flow. So whether you have a shed in that area, or if you're a robotic producer and you have robots that are in the alleyway that are blocking air movement, you're gonna see the same phenomenon where the air will be moving fine up until that barrier, drop completely off on the back end, and those cows on the other side will be experiencing heat stress, even if the cows on the front of it are not. So when we're putting those up, always common sense check. Look for additional barriers, remove them if you can, but make sure you check for those. This is a schematic of an overall fan placement. Yes, this is a compost barn, very similar to what we would see in a freestall, except we'd probably place them along the actual stalls and not just in series. But we're assuming this is our predominant wind direction. So starting here, we're gonna put those banks of fans. These are those 3-foot fans. So 6 to 8, about 6 feet in between them here, 30 feet to the next row, 6 feet between them here, 30 feet to the next row, so on and so forth. And we have those same spacing keys on the feed alley. I get questions about HVLS or LVLS, which is high volume, low speed, or low volume, low speed fans. We don't see many LVLSs in the dairy industry. We see mostly the HVLSs, and the one that we probably think about most in Tennessee and Kentucky would be the big ass fans. For those, our keys are 2 to 2.5 times the diameter of that fan blade. Now this is much narrower than we were originally told when we started rolling out some of these HVLS fans. And that's simply because we know they move air really well directly below them, but they don't throw air around them all that effectively. So air will come out in that pretty tight cone right here and cool that area directly around the fan. But if we had done the previous suggestion of 2 to 3 to a side, so say we had a fan here, we had a fan here, and we had a fan here, and these 2 middle ones were missing, what we would see is cows would bunch underneath this fan, underneath this fan, and underneath this fan. And particularly in a compost bedded pack barn, that creates a lot of additional moisture and a lot of wet spots in the barn. It also has the other unintended consequence of increasing radiant heat load from cow to cow and potentially fly load as well. We don't normally put HVLSs in a way that they could still reach the feed alley. So with these in particular, it is crucial to have supplemental cooling along the feed alley, unless you're feeding directly underneath an HVLS fan. They just don't throw air far enough. And we normally have some kind of barrier here, like a retaining wall or waterers or gates, something like that, that would interrupt airflow. If we think about enclosed barns, I'm just going to talk about these briefly, and then we're going to talk about sprinklers. If you think about a tunnel ventilated barn or a low profile cross ventilated barn, they're both different types of tunnel ventilated barn. The difference with these is they rely exclusively on fans for air exchange and cooling, and these became very popular in cold stress areas, so places like the upper Midwest, the Northeast, where a lot of our housing designs come from. And in some of those areas, we'll also see the use of evaporative cooling cells. The trick with an evaporative cooling cell is water has to evaporate to create that cooling in the air. And we live in a very humid environment. So with that humid environment comes a lot of issues of actually increasing our heat stress on that animal if we use an evaporative cooling cell and we increase humidity in the barn. We talked about earlier that our natural relative humidity tends to be between 70 and 75%. Adding more water on top of that can not be as effective here. Sorry, I'll move on. Another thing would be picking up things like poor air quality as we move along the barn. So pros, they're not dependent on geography or wind direction because you're not relying on natural ventilation at all in this scenario. You're specifically relying on fans to bring air in and fans to move air out, or inlets to let air in and fans to move it the entire length of the barn. And you can provide a very controlled climate, particularly in a place where we experience a lot of cold stress, and you don't want the barn to freeze during the winter. And they can be fully automated. Some cons are they're difficult to cool in high heat and humidity environments, specifically the humidity, because that air that comes in is the only air we're going to get along the entire barn. So we really need to ramp up those fans and increase air exchange dramatically during the summer. Air quality can be a concern, again, because the only air coming to the barn is from a specific set of inlets. So that air is going to pick up ammonia, it's going to pick up humidity from cows breathing out all the way down the barn. So the air quality at the beginning of the barn can be dramatically different than the air quality at the outlets of the barn. And we often need additional fans or baffles to effectively cool cows. So baffles push air back onto the cows. Some engineers are really pro-baffle. Some engineers are really anti-baffle. It really depends on your situation and how you manage it. Same thing with additional fans. But I will say in the Southeast, if you're planning to use some kind of sprinkler system, and we'll go over this again in a minute, but I really want to mention it here. If you're using a sprinkler system in a fully enclosed barn in the Southeast, you really have got to have supplemental fans over the feed alley to drive that evaporative cooling. Because again, we'll feel great air movement down the center of that feed alley, but we won't necessarily have that same high movement over the cow level, particularly in a long barn. So we're gonna go over some if we sees, just real quick. For heat stress and stagnant air, we're really focusing on air movement. So if we have an enclosed barn, the first thing we wanna do is knock out any of this paneling that we can to really open the barn. The big thing I'm gonna say is if it's not structural, we probably don't need it. We need to make sure we have enough fans in the barn. I'm sure y'all have all seen a couple of these retrofit tobacco barns, but the big thing we need to remember is one fan is not sufficient to cool all of these stalls, and it's definitely not reaching these cows over here underneath the overhang. We need to make sure our fans are running at optimum. So broken fans, dust-covered fans, or fans filled with feathers and all kinds of lovely bird's nests, those fans are not running at optimum. So going in there and fixing them or cleaning them out can be really helpful and a really cheap fix to make sure everything keeps running smoothly. We might not have an air outlet, and that's where we would think about putting in a ridge vent. Like I said before, that open ridge is going to be your quickest, cheapest option most of the time, as long as you make sure to take care of those trusses, because we don't want those to rot from any precipitation that does enter the barn. And always, always, always common sense check. If you cannot feel the air movement at the cow level, which means crouching down to see where the cows would be, that fan placement needs to be addressed. Those cooling options need to be addressed. All right, real quickly, we'll talk about the role of water in cow cooling because it's a big role that we play down here. And the first thing I'm going to talk about is the clean water difference. If we have dirty waters, and I know you're all rolling your eyes because you've heard me say this ad nauseum, the cows are not going to drink water. We talked about convective cooling and convective heating, moving from a liquid to another media. Cool water that those cows drink will cool their core body temperature. We see it all the time in rumen boluses, and we're trying to track actual animal temperature. We'll get a big slug of water when they drink, and it drives that core temp down and messes with our data. So we know it really does happen. It really does have an impact. But if those cows are avoiding that water trough because it's dirty, we're not going to see that cooling effect. And we're also not going to see those benefits in production, reproduction, efficiency that we would from having clean water. So this is an easy dumper that, yes, I did roll up my sleeves and clean. It looked like this beforehand. It smelled fantastic. We went in there with a nice little white scrub brush, dumped it a couple of times, and got it back to its shiny new clean self. And I am not kidding you, 5 minutes later, if even that, this was the picture at the water trough. So all of the girls, there's only like 70 in this barn, so we had a good 6 or 7 that were already huddled around the water trough trying to drink that clean water. So can't overstate it enough, guys. Clean water really, truly does make a difference. Evaporative cooling is the other one that we work with. And the big key here is the water has got to completely soak the skin. We cannot effectively mist the air in Tennessee. It does not work here. Our relative humidity is just too high. Places like the Texas Panhandle, New Mexico, Arizona, where they have a lower overall humidity, misting the air and cooling the air works great. But we don't have that type of ambient climate here. So we do not want to use misters in Tennessee to cool the air around the cows. What we do want to do is use a soaker with a large water droplet. And that's what we have that's ideal for high humidity, but we have got to combine it with fans. And this is why we have to combine it with fans. So we have our little jersey here, and let's assume that we wet her skin, okay? Her skin is now wet. Or we don't wet her skin all the way, we don't wet her hair coat all the way down to the skin. What happens if we leave it there and we haven't completely wet her all the way down to the skin is we've effectively created a secondary barrier. And what this barrier will do is trap heat between that water level and the cow's actual skin and compound any kind of heat stress issues that we're seeing. So we have got to soak those girls all the way to the skin in order to effectively cool them with evaporative cooling. And where we live, we have to combine it with fans, because the only way that evaporative cooling works efficiently is if we have a cycle of water on and then water off with fans. So this is for holding pens specifically, and that's why you require multiple nozzles and an 8-foot spray diameter. It's going to be a little bit different if you're spraying down a line than if you're spraying in a holding pen, but we're just going to use this as a reference. So we've got a pen size for 40 cows, 24 feet by 32 feet. We need about 20 gallons of water, and that's going to be a minimum flow rate, gallons per minute, of 10. So this is assuming that we're going to put out 0.025 gallons of water per spray cycle per square foot of pen. So enough out there to really truly soak those cows. We have our gallons per minute based on a 2-minute cycle, followed by a 10-minute fan cooling cycle. This is important, guys. If we don't have those fans, we're just creating another heat source and a heat trap for those cows. So take home messages, and then I'll open it up for questions if y'all have any. We know that heat stress is an issue for most of the year in Tennessee. From April all the way to October, our cows are definitely experiencing it if we're not experiencing it ourselves. And if we can do nothing else besides provide shade to reduce the heat load, that can be a huge benefit to reduce that radiant heat beating down on those cows. It's also a really good strategy if we have dry cows that are on pasture or young stock that's out on pasture as well. They're also going to experience that heat stress. We want to maximize our natural ventilation in barns first because it's free. So whether that is adding a new ridge vent or making sure your ridge is adequately sized, that's the first one we want to look at. We want to remove any unnecessary structures along the sides of our barn to really let that air in and really promote that air exchange and that cooling. We want to fill in with fans and sprinklers as needed, starting with those high impact areas first, like the calving area and the close-up fresh cows, close-up dry cows, and then moving all the way down to our low producers. Once we get into the lactating herd, We want to make sure we put them over the feed alley first. And if we're going to use sprinklers, in Tennessee, we've got to have fans. So quick wrap up. I'll wait for y'all to type questions in the chat or unmute, and I'll call on y'all. If you missed some of this webinar today, that is okay. If you would like to see what you missed, you can go back to the UT Dairy website, and all of the recordings will be posted there. As soon as we wrap up here, I'll start the editing process, and I should have that out for y'all by the end of the day. All of our previous webinars are posted there as well. If you would like to go back and view more of them for Master Dairy Credit, you are welcome to do so. This is the same form for all of the Master Dairy Credit evals. It's https://tiny.utk.edu/tmdp_form. And y'all all have my cell phone number already. Most of you do anyway. If not, there's my office number and my email. Feel free to call with any comments, questions, cries of outrage. And if y'all have any at the end of this presentation, I would love to hear them. Hearing nothing, I'm going to go ahead and end the meeting. Please, please, please remember to fill out the evaluation sheet. That is the only way I know you were here. We've been very fortunate to have quite a few people join us on these. So please follow that link and fill out the eval sheet, and I will talk to y'all later. Thank you for joining us for Weekly Webinar Wednesday. Bye, everyone.
Hey, Liz, can you hold on just a moment?
Of course I can.
Okay. Have you heard anything about what's happening in the dairy industry recently? I understand there's been some changes here. Do you know of anything? Okay, maybe in this area, in the Middle Tennessee area, in regard to people's milk?
As far as what specifically, Ruth?
Where their milk is going, the DFA thing and that type of thing, okay?
So we do know that Dean Foods sold 40 of their assets, or 44 of their assets, to DFA, and that included all of the fluid plants in Tennessee. So far, we haven't been told that there are going to be any changes to the way milk enters those plants. They have said publicly that they plan to honor all the independent contracts that are going into those plants. And there hasn't been a whole lot more on it since then. We're just going to keep watching and waiting and seeing how that develops.
Okay. I just got a little bit of a wind of it, and I don't know anything about it. Just wondering how this impacts our dairy producers.
So I'm choosing to see it as a positive. There is a buyer. Those plants now have someone to keep them running. I'm sure everybody has a little bit of a different opinion on that. I saw a couple people unmute. I'm sure we'll hear it here in a second. But at least those plants now have someone to keep them running. Hopefully things continue to go as normally as we can during quarantine. COVID-19 has definitely had a more severe impact on our production lines than the purchasing of those plants has at this time.
All right, thanks, Liz.
Mm-hmm.
Liz, where is it that we find that form that we're supposed to fill out?
So Sandy, you can find it on the UT Dairy website, or here, let me type it in the chat and then you can copy that over.
Okay, thank you.
I'll send this out to everyone. So just in case y'all are writing this down and you can't see the chat, it is https://tiny.utk.edu and then capital TMDP, Tennessee Master Dairy Producer _ and the word form.
Okay, it's right here on this form. Thank you.
You're welcome. Glad you could join us. All right, well, be sure to join us next week. We'll have our ag economists from UT talking about the coronavirus food assistance program and what kind of impacts, if any, that is going to have on dairy producers directly. And if you haven't already, I would strongly encourage y'all to look into the payment protection program. They did increase funds for that. They pretty much doubled well, not doubled, they put back in the same amount that they had put in before. And that is eligible for people who are self-employed and meet the actual requirement of a small business. And that can be used to pay employee wages. That can be used to pay things like utilities for the farm, or even land rent if you have an actual valid agreement on that. Your managed agents are great resources to talk to about getting started with the payment protection program. It is, or the paycheck protection program, excuse me, PPP. It's only a 2-page application. It doesn't take a whole lot of time, and you can work directly with your local lender. And most farm credit service agencies have been approved. I don't know if any of our managed guys are still on. Les, do you have anything to add to that that I missed or overstated?
It's just that way, we're learning more all the time about what's included, what won't be. So they should have a lot of that coming up here real shortly.
Yeah. Thanks, Les. All right, y'all. Last chance to ask a question before I end the meeting. All right. Thank you, everyone.